check, check one, check, check. check, check one, check one, check. Check one, check.
Sounds. Online students, can you hear me clearly? Online students, can you hear me clearly? Check. Online students, can you hear me clearly? And students in the YouTube live? Students in the YouTube live, can you hear me clearly? Okay. And last row students, can you hear me clearly? Can you? Okay. Okay, so someone around here said me that we have to start from dimensions, right? Is that true? Yes, we have to exactly start from dimensions, right? Okay, so some students are still coming. So I'll give you an additional question. This is a very popular question, actually. Uh, I'll give you an additional question. And some students start the recordings. And pay attention. And some students have finished this. Okay, for them we'll give a book. Okay, we have a whole book with questions like this. Okay, so anyone who finished this, ask from my invigilators. I'll ask them to give you the book with a lot of questions like this. But addition to that, let's do one additional question. Okay, I'll give one additional question. Let's think that, then move to the upcoming parts. Okay, so today mainly we have to start the class with dimensions. But before that, quickly find the answer for this until others reach here. This is a very popular question from SAT exam. Okay, you must have seen this. I mean, if you are into nice questions, pay attention everyone, stop talking. There's a coin of radius 3r. There's a coin of radius 3r. Okay, there's a coin of radius 3r. Another coin of radius r. Another coin of radius r. Okay, I'm gonna roll this around this coin and return to this point again. Clear? I'm gonna roll this coin around this like this. I'm gonna roll this coin around this. Okay, I'm gonna roll this coin around the larger coin and return here. Clear? How many full rounds will I rotate? How many full rounds will I rotate to reach here again? Clear? Got the idea? Write this on an additional book or a leaflet or anywhere. Okay, I don't care. Just questions. Okay, just some questions. There's an issue with the volume. Quickly check online. No, here in the YouTube live. YouTube live students, can you hear now? Can you hear me clearly? Can you hear me clearly, YouTube live students? Let's start with this one, then move to the syllabus today. We are starting from an entirely new topic today. In the syllabus, we are starting from an entirely new topic called dimensions. So if you haven't done the previous parts, okay? If you haven't done the previous parts, it won't matter a lot, okay? If you haven't done the previous parts, it won't matter a lot, okay? But like, just watch the previous recordings for sure. Watch the previous recordings for sure. But if you haven't joined the previous sessions, it won't matter a lot. You will be able to understand to a certain level today, okay? Try to come up with an answer quickly. Try to come up with an answer. And did you? 3. What else? Any other answers? I got one answer. 3. So, like, I mean, was there buses today on the road? Yes or no? Do you know that there's a bus strike, there's a war going on, kind of stuff? Yes, right? So if anyone have any kind of issue with transportation, you can inform us and leave early, okay? Yesterday also we had to finish the classes a bit early. I'm not going to finish the class early. But if you have any kind of issue related to transportation, it's okay to leave early, okay? Because I think there are major issues today. Okay? And I mean the main reason for these major issues is media, okay? I mean not only the media, the government, I mean. There's a war going on. Yes, there's a problem. We slightly understand that something related to oil may occur. But our guy come to the media and tell, don't worry, we have oil. Now everyone runs to the shed to get oil, right? I mean, you just shut up. I mean, like, if you don't tell anything, you say nothing, people don't worry. Then the president, the guy comes and to the media and tells, don't worry, we have oil. Okay, so everyone runs to the shed. So as a result, we don't have oil now, okay? So that's what happens. The main problem is media in the country. Not actually media, how we handle media. Okay? Okay. Let's do this one. Let's do this one. Let's do this one. Okay. Answers. Students who got answer 3. Students who got answer 3. Students who got answer 2. Students who got answer 4. There's a few. Students who got answer 5. Okay, I think it should be 4, right? It should be 4 ideally, I think. Why? What would be the distance traveled by this coin when it rotates one round? What would be the distance traveled by this coin when it rotates one round? 2 pi r, right? Okay. When this rotates one round, it moves a distance equal to its circumference, right? 2 pi r. I mean, that you had something in grade 7 or something like that, right? You create something like this with a circumference of 1 meter. Then when it rotates one circle, no. No, did you do something like that? There's a practical like that in grade 7. Yeah. Did you, was it COVID or Aragal or what? COVID, really? Yeah, in grade 7, you have to create something like that. You create a cycle with 1 meter circumference. So you connect a bell to that. Okay, you connect a bell to that. I mean, what happened to you guys? There's a bell connected to that. So when you just roll it over, move it forward. When it rotates one circle, it rings this bell. So based on the number of rings you heard, you measure the distance. Okay. So if the circumference is 1 meter, when this move 1 meter, if the circumference is 1 meter, when it moves 1 meter, you will hear the ring. So if 5 rings means it's 5 meters. None? Anyone did this? No? No? Really? Okay. What? I mean, anyways, no point of talking about this stuff. Okay. So, when you rotate this by one circle, When you rotate this by one circle, it moves a distance equal to its circumference, right? Which is 2 pi r, okay? Which is 2 pi r. So one rotation means 2 pi r, okay? One rotation means 2 pi r. Clear? Now, what is the total distance that this guy should travel to reach here? It's not this distance, okay? It's not this distance. So ideally, what many of you guys have done is, you take this length, right? You take this length. Clear? What is that length? That length is 2 pi. What is the radius? 3r. 2 pi 3r. Clear? This red color length. But that's not the actual length this coin have to travel. That's not the actual length. Why? I mean, it's not the, it would happen if the coin was connected like this. If the coin was connected like this, then the center of the coin moves in this path. Then the center of the coin moves in this path. Now, in this scenario, center of the coin moves in this path. Is it clear? In this scenario, center of the coin have to move this path, right? Clear? This is the path of the center of the coin. Clear? Clear? This is the path of the center of the coin. Got the idea? Clear? Then that is the actual distance the coin should travel. Got the idea? That is the actual distance, okay? That is the actual distance the coin should travel. Okay? Clear? So the coin should travel a total distance of, what is the radius of this circle? What is the radius of this circle? It is 3r until here, another r here. Clear? So the full one is 4r, right? Full radius is 4r. Clear? The actual radius of this larger circle, is 4r. Clear? Actual radius of the larger circle is, it is going to be 4r. Clear? Got the idea? So as a result, the circumference of this circle, the length of this circle is 2 pi r, but 2 pi r means here 2 pi into 4r. Radius of the path is 4r. Clear? Clear? Which is going to be 8 pi r. Clear? Which is going to be 8 pi r. Clear? So the length the coin should actually travel, is 8 pi r. Clear? And when the smaller coin rotate one circle, it is 2 pi r. So how many 2 pi r's are required for 8 pi r? How many 2 pi r's are required to cover 8 pi r? 8 pi r divided by 2 pi r. 8 pi r divided by 2 pi r. R cancels out, pi cancels out. Here you get 1 and 4. So it is 4 rounds. It is 4 rounds. Clear? Got the idea? So it's actually going to be 4 rounds. Clear? If you need, write this, or else, I mean, you don't actually have to write this. Got the idea? No, you don't have to write this in this anywhere, okay? There's a question. This is just for fun. a small explanation again due to the request. So the actual distance this coin travels is when it rotates like this, when it rolls like this, actual distance this coin travels is this, okay? This is the distance this coin should travel to reach here again, because this is the path of its center. This is the path of its center. So what is the actual distance of this path? It is 2 pi r, and the radius of this path is from here to here it is 3r. Here it is r, so altogether it is 4r. Clear? So it is 2 pi 4r. Clear? 2 pi 4r. That is the actual distance this smaller coin should travel. Clear? That means 2 pi into 4r, which is 8 pi r. And the radius of the smaller coin is 2 pi r. When it rotates one round, it will travel a distance equal to its circumference. Clear? Which is 2 pi r. So one circle of rotation means the distance traveled is 2 pi r. Clear? Then how many 2 pi r's do we need to cover 8 pi r? It is 8 pi r over 2 pi r, you get 4. Clear? Got the idea? I mean, if it was 3, I won't give the question, okay? I won't start with that, okay? Clear? Students, did you understand, online students? Cool. Anyone who didn't get the tute? Anyone? Anyone? Okay, everyone have tutes. Online students, we have delivered majority of the tutes. But today also I'll provide you information on how to get the tutes. And if you have any other issues or if you need to join the group, send a message to this number, 070-154-6825. Send a message to this number if you need to join the group or if you need anything else. 070-154-6825. There's a separate tute courier number. I'll provide that later, okay? I'll provide that later. Okay. Why do I provide the tute courier number later towards the end of the session? Because if you are not staying in the session like for the 3.5 hours, you don't deserve to get the tutes. That's why. Okay. So stay till the end and I'll give you the tute courier number. Let's do it that way. Okay. Let's move forward, everyone. Today's lesson. New concept. Dimensions. Go to page 8. Dimensions. Go to page 8. And pay attention. Anyone who joined new today or anyone who didn't understand anything until now, yesterday we did a session. Yesterday morning we did a session to explain everything we did until now. To cover everything we did until now. A 4-hour session. So today after the class, join the group. We'll provide that link in the group. You watch those 4 hours. That is enough. Okay. That is enough. I covered everything we did until today, yesterday morning within 4 hours. Okay. Clear? So watch that. Watch that 4 hours. Then you are done. Then you can move forward without any issue. Okay. Clear? So stay after the class. Talk with us. Join the groups. Then we'll give you that recording, then you're done. Then you can move forward with the class. And you can see invigilators here and there. If you have any question, please ask, okay? If you have any question, please ask as soon as possible, okay? Because if there's a major issue, if a lot of students are not understanding the same thing, they inform me soon, then I discuss that again, okay? Clear? So you have to quickly inform if you are not understanding something. Okay. Let's move forward. Today's new topic, dimensions. Write the topic on your book, dimensions. In page 8, write the topic on your book, dimensions. dimensions. Okay. Okay. Under that, write symbolic expression that represent any physical quantity. Under that, write symbolic expression that represents any physical quantity. Symbolic representation or symbolic expression that represents any physical quantity. Symbolic expression that represents any physical quantity. That means, can you remember, we learned that there are how many fundamental physical quantities? 7 or 6, I can't remember. 7, right? There were 7 fundamental physical quantities, right? Okay. So, everything else was produced as combinations of these fundamental physical quantities, right? Everything else was produced, okay? Everything else was produced as combinations of these fundamental physical quantities. Clear? Okay. What are the, there were 7 fundamental physical quantities, but at the moment I will focus on 3 main fundamental physical quantities. One is mass. Mass is a fundamental physical quantity. Length is a fundamental physical quantity. Length is a fundamental physical quantity. And the other one is time. And time is a fundamental physical quantity. Okay? Time is a fundamental physical quantity. So many other physical quantities are just combinations of them, right? You take velocity, you take anything, many other physical quantities are just combinations of these fundamental physical quantities, right? Clear? So, in this dimension, in this topic dimension, what we do is we analyze how other physical quantities are connected with the fundamentals, okay? Clear? Something really easy, okay? For that, we give symbols for these fundamental physical quantities, okay? That means we give the symbol, we usually put this sign to show the dimensions. So we give a symbol for mass, we give the symbol capital M. That means this is the symbolic expression of mass, okay? This is the symbolic expression of mass. Then this is the symbolic expression of length. This is the symbolic expression of time, okay? This is the symbolic expression of mass. This is the symbolic expression of length. And this is the symbolic expression of time. Got the idea? Clear? Now, what we are going to do is we are going to see how other physical quantities are connected with them. For an example, take velocity. Take velocity. Okay. For an example, let's start with something simple. Area. Start with area. What is the dimension of area? What is the dimension of area? Area is length into length, right? So it is a length multiplied by another length. So the dimensional representation of area would be L squared, right? Dimensional expression of area would be L squared. Clear? Then you take density. You take density. When you see this, you know that we are asking for the dimension of density. So what is density? Mass over volume, right? Density is mass over volume. So dimensions of density is dimensions of mass over dimensions of volume. Dimensions of volume. Clear? I mean, just don't check the spellings. Okay, I'm not good at English. That means I did literature for English. So until, English literature for O levels. From then I hate English. Okay. So mass over volume. Okay. Mass over volume. Clear? So what is the dimension of mass? What is the dimension of mass? Capital M. Capital M. Then what is the dimension of volume? Length into length into length, right? Dimension of volume is length into length into length, right? Length multiplied 3 times. Clear? Pay attention. So it is L cube. Okay. It is L cube. So M over L cube. Clear? So that is M L minus 3. Okay. ML minus 3. Clear? Got the idea? ML minus 3. So move forward with this stuff. Find the dimension of velocity. First of all, write this part on your on your note. These three, then these 2 examples. Then find the dimensions of velocity. Find the dimensions of velocity. Find the dimensions of velocity. Find the dimensions of force. Find the dimensions of force. Find the dimensions of pressure. Find the dimensions of pressure. Try these 3. Try these 3. Let's start with these 3. I think you are capable of finding the dimensions of work too. Find the dimensions of work. Find the dimensions of work. Try this stuff. Quickly find them. And we are getting 2 common complaints in the class, that it is too fast and it is too slow. So yeah, 2 common complaints. We are getting the both complaints at the same time. Okay. So we need 2 people like me to handle that. I mean, there's someone who looks like me, but anyways. So the solution for that would be, if I'm too fast, we decided to provide another explanation recording every week after the class. Everything I explain will be explained again through a small 1-hour video. Much simply, okay, much simply, every week, the video will be available in the group. So if you didn't understand something in the class, you watch that video every week, then you understand most probably, okay? Clear? Clear? It's okay. Every week, we'll provide another recording with the class. After a few days of the class, if you didn't understand something today, you watch that recording. For the people who feel this is much slow, I mean, if you need us to go faster, there's another solution. I'll be starting another lesson parallelly as a fast class. Okay. Most probably online, maybe 2 hours per week. If you feel like you can handle another class, okay, I mean, you guys have to listen carefully, because I mean, otherwise last week I said that I got my mobile phone first at grade 6, so I learned to handle the mobile phone I learned that it is bad within 2 years. So by A levels, I understood how to handle that. So if you got the mobile phone recently, be careful with that. Okay. Then one guy has gone home and said, okay, our teacher asked us, this is true, okay, absolutely true, okay. And one guy has gone home and said that Janitu has gotten a mobile phone at grade 6, so I need a mobile phone. Okay. So whenever I tell something, listen carefully. Don't misinterpret stuff, okay? So again, for the people who can go faster, I'll be starting very soon. I'll be starting another session, 2 hours per week, additional lesson. If you feel that you can handle 2 lessons parallelly, you can watch that too, okay? You can watch that too. But if you don't need that, don't watch that. Why? Those stuff will be explained again in the class, okay? Someone who watch that lesson can move very fast in the syllabus, but that is not necessary. Anyways, those sessions will again happen in the classes, okay? So it's not a must. If you feel like you can do 2 lessons parallelly, and if you need to move faster in the syllabus, watch that. Otherwise, just forget that. Okay? Anyways, for everyone, we are finishing the syllabus before 6 months to the exam. If you feel like you need to finish the syllabus way before that, like 1 year before, you can start watching that session too. Okay? So I repeat, it's not a must. It's something additional. If you feel like you can handle 2 lessons, you watch that. Otherwise, you entirely forget that. Okay? Clear? So velocity, dimensions of velocity. What is the dimensions of velocity? What are the dimensions of velocity? It is a length divided by time, right? Displacement over time. So length divided by time, right? Length divided by time. Okay. Velocity means length divided by time. That means LT minus 1. Okay. That is LT minus 1. Clear? Length divided by time. Okay. Then what is the dimension of force? How can I get this? I'll use something I know. F equals MA, right? F equals MA. So dimensions of force is equal to dimensions of mass into dimensions of acceleration. F equals MA. Pay attention, everyone. F equals MA. Clear? So dimensions of mass is capital M. Dimensions of mass is capital M. Dimensions of acceleration is LT minus 2. Clear? LT minus 2. Clear? You divide velocity by time, again you get acceleration, right? You take velocity LT minus 1. You take velocity LT minus 1, divide it by time, again you get acceleration, right? So dimensions of acceleration is LT minus 2. Dimensions of acceleration is LT minus 2. You get the velocity, divide it by time, again you get the acceleration. So acceleration is LT minus 2, mass is M. So this is the dimension of force, okay? This is the dimension of force, okay? Clear? Clear? Let's move forward. Dimensions of pressure. Dimensions of pressure. Pay attention. What is pressure? Force over area, right? Pressure is force over area, clear? Pressure is force over area, clear? So what is the dimension of force now? Now we know that, we just found that, right? We just found that. What is that? MLT minus 2, okay? MLT minus 2. MLT minus 2. And the area is length squared, right? Area is length squared. So this L and this L cancels out. You get M. You get M. You take this up. L minus 1. You take this up. L minus 1. T minus 2. T minus 2. Okay. Next, work. Work. This is the dimension of pressure. Dimension of pressure. Clear? What is the dimension of work? Did you have any like in your syllabus? Did you learn any definition for work? Yes or no? Force into displacement, was it there? I mean, I can actually remember, that's why. It was there, right? So we can use that. Work equals what? Force into displacement. Work equals force into displacement. Clear? That means you get dimensions of force multiplied by the dimensions of displacement. What is force? We just got that. Force is this, MLT minus 2. MLT minus 2. Then displacement is again L, right? Displacement is again L. Clear? Displacement is L. Clear? Then we get what? We get M L squared T minus 2. Clear? This is the dimension of work. Clear? This is the dimension of work. Write this stuff. So can you see in page 8, there's a lot of dimensions shown, okay? In page 8, there's a lot of worked examples. As I always explain, don't study them, okay? Don't study them. You will just get to know them, okay? With time, you will learn about these stuff. So don't study them, okay? Clear? Just let them be, okay? With time, you will anyways remember them because you will be again and again working with these dimensions. Clear? Okay. Okay. Let's move forward. Let's move forward. Okay. So you guys have moved there, right? You guys have moved there, right? You see. Okay. Let's move forward. Features of dimensions. Let's move forward. Features of dimensions. Did you understand the basic concept about dimensions? Okay. There are some features about dimensions. Anyone who joined the 2 previous classes will find this extremely easy. Why? Features of dimensions are almost equal to the features of units. Okay? Features of dimensions are almost equal to the features of units. Why? Unit represents a physical quantity, and at the same time, dimensions represent a physical quantity too, right? Clear? Units represent a physical quantity, so at the same time, dimensions represent a physical quantity. So the rules are, you can't add different dimensions. That means you can't add a mass with a length. Clear? You can't add different dimensions. You can't add a mass with a length. You can't even subtract, okay? You can add a mass with another mass, then you will get another mass, right? Clear? When you add a mass to a mass, you will get a mass. That's all, right? If you subtract a length from a length, you will just get a length. Okay? Clear? So as a result, if you have an equation like this, P equals Q plus R, dimensions of this term, dimensions of this term, and dimensions of this term should be equal. Clear? Okay? Dimensions of this term, dimensions of this term, and dimensions of this term should be equal. If this is a length, this should be a length. Then length plus length, you just get a length, right? Clear? But you can do anything related to multiplication and division, right? You get a length, you divide it by time, you get the dimension LT minus 1, which is velocity. So you can do multiplication and division between any dimension, not addition and subtraction. Clear? Not addition and subtraction. Clear? Then at the same time, numerical values don't have dimensions, okay? Number 5, pi, e, these are just numbers, okay? E is a number, okay? Just know that. What is E? I can't remember the value. Anyone? Maths people? Did you learn about E? What is the value of pi? 3.14, 22 over 7 is 22 over 7, right? 22 over 7 or something like that. What is the value of E? Can't remember. Online students, just search and put the answer quickly. It is approximately 2.71828182845. Like pi, it never stops, okay? Like pi, it never stops. So E is also a constant, okay? E is also a constant. Pay attention. It is 2.7182. 2.7182 and it goes on, okay? Clear? Especially bio people learn this stuff, okay? Because I can remember one time in A-levels, I mean, if we don't tell this stuff, you never get to see this stuff, okay, bio people, okay? So, one time in A-levels, I can remember, there was a properties of matter question. Question number 8, as I remember, and full essay question. They gave an equation with E. The person who made the paper felt so normal about that. It's just a constant. You don't get frightened when you see pi in an equation, right? It's just a value. Okay? When you see pi in an equation, you don't get frightened, right? But in that, there was E. There were some bio people who have never seen E. So just think that you don't know pi. For the first time, in an equation, you see something like this. Okay? In A-levels. Okay? After working for 2 years for A-levels, all of a sudden you see something like this and you don't know what is pi. Now you have no idea about what to do next, right? Is this a constant? Is this a variable? Is this something like x? Is this something like y? Or is there a number? You have no idea, right? No clue. So now you are in trouble, right? So the same thing happened in that year. Some bio people haven't seen E. If they knew that it is just a number, they would just consider it as a number and move forward with that. When you have pi, you either replace it by 3.14 or you just let it stay as pi and move forward, right? But many bio people didn't know to do that with E because they have never seen E. Okay. I mean, what the hell are they supposed to do? It's in A-level exam, okay? So these kind of stuff happens, okay? These kind of stuff happens. They sometimes forget that the bio people are right in the physics paper, okay? So, so that's why this Thursday also, as I mentioned, we are starting the maths program to teach all the maths parts required for bio people. You can either watch online, watch the recording, or join physically, okay? This Thursday morning, as I remember, 8 to 10:30 English medium, 10:30 to 11 to 1:30 singular medium, as I remember. Okay, we'll be teaching all the maths parts. I got the syllabus. I'll provide that now in the group. Okay. So bio people take small maths parts like this serious. Okay, try to remember them. I mean, not the value, just the mathematical common sense. Because sometimes the people who make the paper, they forget these stuff, okay? Clear? And especially the IT people, the other kind of people. They sometimes forget that IT people are writing the paper. So they start asking about atoms, use relative molecular mass, okay? Now again you are in trouble, okay? So IT people take small chemistry stuff you are learning in physics, take them serious. And bio people, small mathematical stuff like this, take them serious, okay? Clear? Because it matters. It doesn't matter for you. I mean, it actually matters for your marks. Why? That year, then they decided to give all for that part. It was question A, question B, and question C. You had E in the question B, so they decided, okay, it's not fair for bio people. So they gave all to this question. Then they distributed the marks in this area to this one and this one. But the time you wasted figuring out what is E, you are not going to get marks for that, right? Clear? They can just distribute the marks away, okay? But the time you were wasting and the mental impact you got as a result of seeing something alien in your paper, okay? You're not going to get anything for that, right? So have to be careful about like small maths parts, okay? I usually cover everything as a result, okay? I mean, if possible, I teach everything because I mean, although you are bio, you can't skip maths parts because the same reason, the people who make the paper, they sometimes forget because it's in their common sense. That's why. For them, E is very normal. So when they are making the paper, they just write T and they feel normal about that. See how it happens? Because these are the people who know maths and physics to an extreme extent, okay? So these kind of stuff are common sense for them. So they forget that there are people who don't know these things, okay? That's what happens in A-level papers sometimes. Okay? You didn't have this kind of issues in O-levels, okay? So there's a lot to manage in A-levels. Okay, let's move forward. So these kind of numbers don't have dimensions. These are just values, okay? These are just values. Pay attention. Then the next one. The next one. Again, trigonometric ratios won't have dimensions. Why? That means sin theta, cos theta, tan theta won't have dimensions. Why? Theta is A, B, C. So sin theta is A over B. Sin theta is A over B. That means a length divided by length, right? Length divided by length. Clear? Sin theta is length divided by length. So dimensions cancel out. So sin, cos, tan, trigonometric ratios don't have dimensions. And at the same time, a power can't have a dimension. That means 5 to the power. You can't have 5 to the power a certain mass, right? You can't have 5 to the power a certain length. Clear? So 5 to the power anything A should be dimensionless, okay? A should be dimensionless. A power can't have a dimension because you can't put a physical quantity here, okay? You can't put a physical quantity here. So this must be dimensionless. Clear? You can't put a physical quantity here. So this is how we write the term dimensionless. A, dimensions of A is just 1. That means there's no actual dimension here. Clear? Dimension of A is just 1. There's no actual dimension for A. Clear? A power can't have a dimension. Okay. Moving forward. Okay, that's a good question. I'll answer that. Okay. Okay, let's move forward. Again, the function called log something to the power. Let's take 10 to the power p equals q. You can't put anything with a dimension into this function, okay? You can't put anything with a dimension into this function, okay? Log is a function, log was not there naturally. Some mathematicians introduced the function called log. When they were introducing the function called log, they said what can and what cannot. So when they were introducing this function, they said that, okay, you can't put any physical quantity into this, just put numbers, okay? Clear? Just put numbers. So when you are using the function called log, it is dimensionless. And the same mathematician said that anything you are getting out of this function is also dimensionless, okay? Same mathematician said anything you are getting out of this function is going to be dimensionless, okay? It is going to be dimensionless. Clear? So P is dimensionless and Q is dimensionless, okay? Let's move forward. Next. There are some physical quantities that don't have dimensions, okay? For an example, we learned last week. Take relative density. Relative density means density of something divided by density of water. Relative density of something means density of something divided by density of water. Clear? So here this is a density m, dimensions ml minus 3. Again here this is the density ml minus 3. So they cancel out. Clear? So there are physical quantities without dimensions. Clear? There are some physical quantities without dimensions. Got the idea? Then moving forward. Take the angle. Take the angle. Now, can you remember the official definition of an angle? Can you remember the official definition of an angle? What is the official definition of an angle? The definition of radians. This is S. This is R. So new students, these are the stuff you have missed, okay? So watch yesterday's session, it's just 4 hours. Then you can cover everything that we did until now, okay? Yesterday I met some people, they are just new to A-levels. Then I asked why. You just finished O-levels, so you can't just come to the classes the next week. It was a very good explanation, by the way. You can't just come to the classes within a week after finishing one exam. So we just waited for 2 weeks, which is very reasonable. Okay, can't tell anything about that, right? So now they are here. So it's reasonable. Okay, if you are today for the first time in A-levels, it's reasonable. Can't blame. Okay, I mean, so but watch the recording of the last. Just watch that recording, then you are done with everything happened until now. Okay, so can you remember this? Theta is S over R in radians. Can you remember? Theta is S over R in radians. Can you remember? S over R in radians. Clear? So the unit of angle is radians, right? See? Unit of angle is radians. Can you remember? But what is the dimension of angle? According to this definition, what is the dimension of an angle according to the definition, according to the official definition? S is a length. S is a length. Clear? And R is a length. Clear? R is a length. S is a length and R is a length. So the length to length cancels out. So angle is dimensionless. Clear? So there are some physical quantities. Okay? There are some physical quantities with units but dimensionless. Clear? Angle has a unit, radian, but it is dimensionless. Clear? Got the idea? But it is dimensionless. Okay? Clear? So it's a different scenario. Okay? It's a different scenario. Clear? Okay. Let's move forward. So there are a few other examples too. For an example, this is radian, steradian, sound intensity level, decibel, these kind of stuff you don't have to remember. Again, you will get to know them in the future lessons. Okay. So here you may see a lot of stuff included in the note I skip. Because there's no point of trying to explain you about the sound intensity level at the moment. Okay. There's a separate lesson for that. Then you will learn. Okay. So there's no point of wasting time explaining something you have no idea about. For an example, becquerel, a unit used to measure radiation. What is radiation? You have no idea at the moment. So what is becquerel? I have no point of talking about that, right? So that's why I'm skipping some areas. Okay, don't worry about that. There are lessons to learn about them. Okay, clear? I just like to make things efficient. Okay, no point of wasting your time explaining something you have no idea about. When there's an entire lesson about that unit, okay, you have an entire lesson about becquerel. You'll be writing that unit like 1,000 times in that lesson. So no point of learning about becquerel at the moment, right? Clear? We have to make things efficient. Okay. Okay, so these are the basic common sense. Okay. These are the basic common sense about dimensions. Okay. Got the idea, everyone? Okay. Basic features of dimensions. Okay. Let's go to exercise 3. Let's go to exercise 3. Yes, refractive index is also a correct answer. Refractive index is also a correct answer. It's true. Okay. So let's move forward. Go to exercise 3. Go to exercise 3. Exercise 3 in page 13, but I need you to move to page 14, questions. Do question 2, question 3, 4, 5 and 6. Finish these questions. And if you need any unit or dimension of a term that you don't know, you have a table in the last page, okay? You have a table in the last page. If there's a unit or a dimension that you don't know, you can get that from the table, okay? And again, don't study that table, okay? Quickly finish the questions. Question 2, 3, 4, 5 and 6 of exercise 3. Online students, inform in the chat if you can't find the tute, but you can find the tutes in the resources section of the webinar. If you like, you can write them in the main book, or you can write them in a separate book. And YouTube live students, it's available in the chat. And for you guys, it's available in the resources section of the webinar. Okay? For the students in the Zoom. And students, online students, definitely set up your online websites by next week. Okay? We can't just keep putting the link and the live link in the group, because I mean, the institute is asking us why. We just put it because I mean, today also there's a transportation issue and all. For an example, exercise 3 question 2, n equals n naught e minus lambda t, n equals n naught e minus lambda t. N and n naught represents the number of atoms, t represents time, and e is a numerical value, dimensions of lambda. So the idea is this term can't have dimensions, right? This term can't have dimensions. Why? A power should be dimensionless. Can you remember? A power should be dimensionless. So if t represents time, dimensions of lambda should be 1 over time, right? If t represents time, dimensions of lambda should be 1 over time, then only they may cancel out and will be dimensionless. Clear? So dimensions of lambda is 1 over t. Clear? If I write it properly with the steps, lambda t. So minus lambda t means minus 1 into lambda into t. Minus lambda t means minus 1 into lambda into t. It's the power. A power should always be dimensionless. Okay? A power should always be dimensionless. Then dimensions of minus 1, dimensions of lambda, and dimensions of t equals 1. Clear? Dimensions of minus 1 is dimensionless, right? Minus 1 is just a numerical value, right? Minus 1 is just a numerical value. So numerical values are dimensionless. Okay? I need to find the dimensions of lambda. Dimension of time is capital T equals 1. Then I can write lambda equals 1. You take this t down, 1 over t, which means t minus 1. T minus 1. Okay. Next. Third one. Question 3. Question 3. Question 3. Question 3. L equals 10 log I over I naught. I over I naught. L equals 10 log I over I naught. Dimensions of L. You need to find the dimensions of L. That is equal to the dimensions of 10 log, pay attention, I over I naught. 10 log I over I naught, which is equal to the dimensions of 10 and log I over I naught. Log I over I naught. Clear? Dimensions of 10 and dimensions of log I over I naught. 10 is dimensionless, just a number. Function called log never outputs a dimension. Can you remember? 10 is dimensionless, anyways, just a number. Function called log never outputs a dimension. Clear? It is just 1. Clear? It is just 1. So you get just 1. Okay? So sound intensity level is 1. That means the dimensions of sound intensity level is 1, which is dimensionless. Clear? It is dimensionless. Clear? Okay. Quickly ask if you have any questions, okay? Got the idea? That means it's just a rule, okay? Just a rule. You get the dimensions of 10 log I over I naught. You have dimensions of 10 and dimensions of log I over I naught. 10 is just a number, just a numerical value. A numerical value is not dimensionless. A numerical value is not a physical quantity. So it is dimensionless. And as a rule, we learned that the function called log never outputs a dimension. The function called log never outputs a dimension. So this part is dimensionless, this part is dimensionless. That means there is no resultant dimension. Clear? Is that clear, the student who asked this online? Is it clear? The student who asked it online? Nice. You can just keep it like this. This means dimensionless, okay? You can just keep it like this, okay? Just keep it like this. Okay. Question 4. Question 4. Question 4. So you just have multiplied two dimensionless terms, that's all. You have multiplied two dimensionless terms. This is dimensionless and this is dimensionless. So you are not gonna get any dimension out of it. Clear? Moving forward. Y equals, pay attention, y equals K1 sine K2t. So can you remember we learned two rules related to this. What are they? One is into a sine term what we put is an angle, right? Into a sine term what we put is an angle. And angles are dimensionless. Can you remember? Angles are dimensionless. from this one, from this example? Angles are dimensionless. Clear? See, it's a length divided by a length, right? It's a length divided by a length. So one rule that we are going to use is that the angles are dimensionless. Clear? And the other rule we are going to use is, can you remember that I mentioned that sine terms never outputs a dimension? Can you remember? Sine terms never outputs a dimension, right? Clear? Sine is dimensionless, cos is dimensionless, tan is dimensionless. Clear? So that means dimensions of y, before getting into that, let's start it here. K2 into t is an angle. Just know it as a fact, angles are dimensionless. Clear? So, this term K2t, this term K2t is dimensionless. Clear? This term called K2t is dimensionless. Clear? Because it is an angle. And why? You can put angles into sine function, right? Nothing else, right? What do you put into a sine function? Always an angle, right? Clear? So this is an angle. So dimensions of K2t is dimensionless. It is 1. Clear? Then we get dimensions of K2 into dimensions of t equals 1. Then we get dimensions of K2 into time equals 1. Pay attention. Dimensions of t is time, right? So what is the dimension of K2 then? Dimension of K2 is 1 over t. 1 over t. Clear? Dimension of K2 is 1 divided by t. Clear? 1 over t. Which means t minus 1. Okay? T minus 1. Okay? Then the next one, next part, I need the dimensions of K1. How? Can you remember there's another rule? In an equation, dimensions of this side must be equal to the dimensions of this side, right? In an equation, dimensions of this side should be equal to the dimensions of this side. Clear? So we write dimensions of y is equal to the dimensions of K1 sine K2t. K1 sine K2t. Clear? Then you get this is equal to K1 and sine K2t. Clear? You separate them. This is the dimension of y. Then we know as a fact, y is displacement. Y is displacement. Displacement is a length, right? Displacement is a length. That means it is capital L. Clear? It is going to be capital L. Clear? Equals dimensions of K1 equals dimensions of K1. Clear? Into sine terms never outputs a dimension. Is that clear? Sine terms never outputs a dimension. Clear? Sine terms are dimensionless. And this is K1, dimensions of K1, and this side I have L. So what is the dimension of K1? It is L, right? Dimension of K1 is L. Okay? Dimension of K1 is length. Quickly write this down. Yeah, definitely. That's an error from our side. Okay, we should have used this like this. Otherwise, you don't know whether t is outside the sign term or inside the sign term. It's an error from our side, okay? Okay, just correct that. Okay, otherwise, when you don't have these two, you don't know whether t is outside the sign term or inside the sign term. It's an error from our side. Okay, quickly write this down. About the exam. I mean, you're not going to get marks for that, okay? As I explained, the surprise exams are not actual exams, okay? I mentioned that surprise exams are not actual exams. That means we are just correcting them. We see what we can do, how the syllabus should be produced, everything, all the information that we need to get, and then it's done, okay? Surprise exams are like that, okay? We are not going to do anything about that. We just get the information, gathering information, okay? Surprise exams are for gathering information. That means even today, we can give you a 10-minute exam. You just do that, we collect them, then that's done. We just check whether everyone know the concept. That's all. Clear? Then we gather information. We see if many students haven't understand the concept again. I do an extra class for that part, or I explain that in the main class. So surprise exams are just there for information. When there's a proper exam, we'll inform 1 month before, okay? Clear? Take those exams serious, okay? We are going to do that properly. You are going to be seated properly under all the exam conditions, and we are going to publish the top 10 list and do everything properly when it comes to main exams. Surprise exams, you don't have to worry about them, okay? Nobody knows the marks, okay? It's just for information, okay? We just need information. So whenever I feel I give a small exam, 10 minutes, 5 minutes, 15 minutes, 20 minutes, sometimes 1 hour, 2 hours, but we are not going to take the marks serious. We are just collecting information from them, okay? We just need to know whether students know the stuff or not. That's all. Clear? It's for, and at the same time, you can check whether you can handle the question or not. Okay? That's all about them. Okay? So don't take surprise exam serious, okay? It's just for the sake of getting information. Yeah, there's a request to explain the second one again. I'll move to that again after doing the other question. Okay. Question 5. Question 5. Question 5. Pay attention. I equals C log K over L, right? K over L. K over L. L represents displacement, C represents velocity. What are the dimensions of K and L? K and I think, right? So one thing, you have to write steps in dimension related questions, okay? Write things properly, okay? At least for the, anyways, you are not getting dimension related questions for A levels, okay? You will get maximum 1, okay? 1 MCQ most probably. But for the first term test and all, they ask these stuff, okay? So write the steps properly, otherwise there's nothing to write in the first term test, okay? Clear? And I think you're not going to get your marks for O levels either, right? Any soon? I think paper marking is not happening properly at these days, and practicals now there's no very certain day, so yes. What are you doing? There's a verse here. Raise your hand and get the verse. Okay. Okay. And when you get your O-level marks, now you are a bit serious about that, right? Pay attention. by time, maybe after 3-4 months, I mean, you have understood the difficulty of A level, so when you get your O level marks, you don't care anymore, okay? You just don't care. You don't care about your O level marks. You have bigger problems in your life by then. So just believe me, okay? When you get your O level marks, you don't care about your O level marks anymore, okay? You already know that O level marks doesn't matter anymore. So you actually don't care when you get O level marks. You have bigger problems in your life. You have to understand stuff happening in physics, okay? It has become a better problem in your life, okay? So just believe me, you're not going to take your O level results serious. None of you, for sure. Okay. I equals C log K over L. L represents displacement, C represents velocity. So the first thing, we are going to use one rule for this. What is that? Pay attention. We are going to use one main rule for this. What is that? You can't put anything with dimensions into the function called log, right? You can't put anything with dimensions into the function called log. So this one, K over L is going to be dimensionless. Clear? This one, K over L, is going to be dimensionless. Okay? Then you have K and you have L equals 1. K over L equals 1. Then you get K, dimensions of K equals, you take it here, equals dimension of L, which is equal to what? L represents displacement, which is a length, so it is going to be capital L. Clear? L means displacement, which is a length, so it's going to be capital L. Let's move forward. The next one, the dimensions of I. How can I get them? There's a rule, dimensions of this side of an equation should be equal to the dimensions of this side of an equation. So dimensions of I, pay attention, is equal to the dimensions of this side. C log K over L. C log K over L. Okay. So now this is I. Pay attention. This is I. This C, then log K over L. Another rule that we learned just now. What is that? A log function will never output a dimension, right? A log output of a log function is dimensionless. Clear? Output of a log function is always dimensionless. Clear? Then what is C? C is velocity. C means velocity. Dimensions of velocity is LT minus 1. Dimensions of velocity is LT minus 1. So dimensions of I is LT minus 1. Clear? Dimensions of I is going to be LT minus 1 because this part is dimensionless. Clear? So at what time do we give the interval? Is it 5? Yes, right? Okay. Let's move forward. Let's move forward. Here. Just online students, inform if you need me to explain again, something again. Someone asked this. I'll quickly go through this. This is a power. This is a power. So power is dimensionless. So the term minus lambda t means minus 1 into lambda t. A power should be dimensionless, which means 1. Then I get dimensions of minus 1, dimensions of lambda, dimensions of t. Minus 1 is just a numerical value, so the dimension is going to be 1. This is lambda. Dimension of t is capital T, time. So lambda can be written as 1 over t. Lambda can be written as 1 over t, which is t minus 1. Which is t minus 1. Clear? Got the idea? The students who asked this online? Okay. Valid concern. I'll look into this. Okay. Okay. Let's move forward. Question 6. Question 6. Question 6. y equals a sine theta x, theta to the power x. Y equals a sine theta to the power x. Just at least write a chit if you need me to explain something again, and no, just inform the invigilators quickly. Okay, then I can explain them again, okay, at least after the interval. Y equals a sine theta to the power x. If you are not informing us within the class time, we can't do anything about that, okay? So you have to inform as soon as possible, okay? Just inform as soon as possible. Okay. So y equals a sine theta to the power x, okay? Y equals a sine theta to the power x. A represents displacement. Find the dimensions of theta, x and y. Okay. Pay attention. X is a power, right? Pay attention. X is a power, right? So a power is always dimensionless, okay? That's not a big issue, right? X is a power, so power is always dimensionless. That means just a number. X should be just a number, right? Clear? X should be just a number. Clear? Then theta, again theta should be dimensionless, right? Why? Pay attention. Assume that theta is a length. Then length to the power certain number. Let's assume for an example. Pay attention. What is x? Let's assume that x is 3. Let's assume that x is 3. Then if theta has dimension L, then this becomes L to the power 3. If theta has dimension L, then this becomes L to the power 3. But the problem is this term should be dimensionless, right? This term should be dimensionless. Clear? Because it is an angle, right? At the end of the day, what you put into a sine term is an angle, right? So this whole term should anyways be dimensionless, right? Clear? This whole term should be dimensionless. So for sure, theta should be dimensionless. Why? If theta is dimensionless, any power of theta would be again dimensionless, right? If theta is dimensionless, any power of theta would be dimensionless, right? Clear? Got the idea? If theta is just a number, any power of theta is again a number, right? So theta should be dimensionless. Then the next rule, dimensions of the both sides, dimensions of the two sides of a equation is again it should have equal dimensions, right? Two sides of an equation, okay? Two sides of an equation should have equal dimensions, clear? So here the dimension y, here it is this, clear? So what is the dimension of y? That's what we need to find, right? So we can write this dimension of A, dimension of sine theta to the power x, clear? Then what do I get here? What do I get here? A is given as a displacement, right? A is given as a displacement. So it is L. It is L. A is given, pay attention. A is given as a displacement. So it is going to be L, the length. Clear? Sine term never outputs a dimension, right? A sine term never outputs a dimension, right? Sine terms are dimensionless, clear? Sine terms are dimensionless, clear? Sine terms never output a dimension, clear? So this is going to be, the overall dimension is going to be length, clear? Overall dimension is going to be length, clear? Okay? Okay. So time to time, I move away from the syllabus and move forward with some additional stuff, okay? Some additional stuff in the sense things that required for A levels, but not in the main syllabus. For an example, last week we learned a bit about graphs, right? Can you remember? Last week we learned a bit about graphs. Why? Around 20% of your marks in A levels will depend on graphs, okay? Clear? But there's no, in the syllabus, you won't see any place that they teach about graphs. But 20% of your marks depends on the graphs, okay? Around 20% of the total questions, you have graphs included. But nothing in the syllabus teaches you about graphs, okay? So like that, we have to learn some stuff additionally to the main syllabus, okay? Clear? So I'll give you the interval, but after the interval, draw these graphs in a piece of paper, okay? Just take a leaflet. Oh, sorry, I think just get the leaflets when they give, okay? You can do something with them, okay? So draw these graphs. Y equals 4x plus 3. Y equals x squared. Y equals x squared plus 4. Y equals root x. Y equals root x minus 2. Let's start with these graphs. Just take a leaflet and draw these graphs after the interval. And pay attention. Again, y equals minus x squared plus 2. Pay attention. I just need rough graphs, okay? That means I don't need the values or anything like that. For an example, y equals 3x plus 2 means, y equals 3x plus 2 means this is x, this is y. When x is 0, y is 2. When x is 0, y is 2. Clear? When x is 0, y is 2. Then y is going to improve with x. That's all. Clear? That's all we expect, okay? Clear? That's all we expect. Clear? Just a shape like this, okay? Not the values or anything like that. Just a rough shape. how the graph would look like. That's all, okay? Not a perfect graph or anything like that. So draw them. I'll give you the interval. It's 52. So be here around this time. Is it too much? So be here on time and start doing these questions. Just draw rough sketches of these graphs. Okay. Check. Try to finish one by one. Try to finish one by one. Draw the graphs. Okay. Okay, let's start one by one. Y equals 4x plus 3. Y equals 4x plus 3. Okay. So this is x, this is y. At x equals 0, y is 3. What do we call this? The intercept, right? This is the intercept. Clear? When x is 0, y is 3. Then after that, with x, y keeps growing, right? Clear? After that, y keeps improving. Y keeps improving with x, right? Okay. With x, y goes up. Clear? Y goes up. Y keeps going up with x. Clear? Okay. Next one is y equals x squared. What is y equals x squared graph? Y, x. It's just gonna improve faster, right? That's all. It's gonna improve faster. That's all. That means this is y equals x line. This is y equals x line. What is y equals x line? 0 to 0. When x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. When x is 4, y is 4. It keeps going like this. 5 to 5. 6 to 6. This is y equals x line. Now, this is x and y equals x squared. Y equals x squared. When x is 0, y is 0. When x is 1, y is 1 squared. Y is 1 squared, which is again 1. When x is 2, y is 2 squared, right? When x is 2, y is 2 squared. 2 squared means 4. Clear? When x is 2, y is 2 squared. So if we check the points, 0 to 0, 0 to 0, 1 to 1. When x is 2, y is going to be 4, right? When x is 2, y is going to be 4. Drawing the positive side would be enough, okay? When x is 2, y is going to be 4. That means for the value 2 of x, y is going to be, for the value 2 of x, zoom here, for the value 2 of x, y is going to be 4. Clear? So the graph would look like this, right? So the graph would look like this. It improves faster. It improves faster. Clear? It improves faster than y equals x. Clear? Got the idea? Write this down. With this, you don't need this part, okay? I just use this for explanation. Here. Focus on both. This is y equals x squared. This is y equals x squared. With x, y is going to improve faster. Clear? Y is going to improve faster with x. Next. Next one. Y equals x squared plus 4. Next one is y equals x squared plus 4. Next questions are y equals x squared plus 4, y equals root x, y equals root x, y equals root x minus 2. Y equals root x minus 2. Draw them quickly. Y equals x squared plus 4, y equals root x, y equals root x minus 2. And by next week, I think we'll be able to provide the discussion recording for this paper. Full discussion recording for the paper, and we'll give the next one, okay? We'll give the next one by next week. If you are not able to do these questions, don't worry about that, okay? These are some additional stuff. Okay, let's move forward. Next. Y equals, what is y equals x squared? Shape of y equals x squared is, this is y, this is x, and y equals x squared looks like this, right? Y equals x squared looks like this. Clear? Then what is y equals x squared? Y equals x squared plus 4. What is y equals x squared plus 4? Y equals x squared plus 4. You just improve this by 4, that's all, right? You just lift this up, okay? You just lift this up by 4, right? Clear? Same graph, clear? Same graph lifted by 4, right? That means for every value of y equals x squared, you always add 4. So the same graph you lift by 4, clear? Next, y equals root x, y equals root x. This is y equals x squared plus 4. Y equals x squared plus 4. Next one. y equals, next one is y equals root x. What's going to be the shape of y equals root x? This is y, this is x. What is going to be the shape of y equals root x? Again, this is y equals x line. This is y equals x line. That means 0 to 0, 1 to 1, 2, 3, 4. This is y equals x line. 5 and 5. Okay. So let's use few values. Few values means x, then y equals root x. Y equals root x. So for x equals 0, root 0 is 0. For x equals 1, root 1 is 1. Clear? Root 1 is 1. Clear? For x equals 1, root 1 is 1. Clear? For x equals, let's take 4. What is root 4? Root 4 is 2. So 0 to 0, 0 to 0, 1 to 1, 1 to 1. Clear? Then 4 and 2, right? When x is 4, y is, when x is 4, y is going to be 2, right? When x is 4, y is going to be 2. So we would get a graph like this. Clear? We would get a graph like this. Clear? This is y equals root x. This is y equals root x. This is y equals root x. Yes, online students, yes. Like PDF your answers, then send to this one, 070-154-6825. 070-154-6825. PDF your answers of that page, or just take photographs and send to this number. If things are quite good, it need not to be 100% accurate. If things are quite good, we'll send you the PDF of that book, okay? We'll send you the PDF of that of the next hard question book. And for physical students, if you do a slightly good job on that paper, which is anyways difficult, okay? You don't need to be good at that. But if you try that, and if you have a sufficient set of answers, just show to our invigilators. They will check it a bit and give you the book with the other set of hard questions, okay? That's a full book with hard questions. Entirely unnecessary for A-levels, okay? It is entirely unnecessary for A-levels, but you need a brain for A-levels, so improving the brain is good, okay? That's how it goes. Let's move forward. So I have y equals root x. This is y, this is x. I have y equals root x. Okay. Y equals root x. Clear? I have y equals root x. Then what is y equals root x minus 2? What is y equals root x minus 2? The same graph shifted 2 units down, right? Same graph shifted 2 units down. Clear? Clear? Same graph, you move it 2 units down. Clear? Because always it's y equals root x but minus 2. Okay? Y equals root x minus 2. Clear? So it is, this is y equals root x minus 2. Y equals root x minus 2. Y equals root x, then you move it down by 2 units always. Okay? You move it down by 2 units. Okay? So last row people, pay attention. Check. Question? Okay, okay. Okay. Y equals root x minus 2. So check other questions. Y equals minus x squared plus 2. Next one will say y equals minus root x plus 3. Y equals minus root x plus 3. Y equals y minus 5 squared equals x. Draw graphs for these. So just send it to this number. If you are done with that tute, okay, online students, if you are done with that tute, send to this number. Is this the tute delivery hotline? No, another number. Okay. We are using a separate number for that, then it's easy to check. Easy for us to check. 071-996, 071-996, 6615. 071-996, 6615. Send a photograph of your answers to this, okay? Try, quickly draw the graphs. Next set of graphs. There was a request to explain root x again. I'll explain that again anyways. And just let me know if you need me to explain. Okay. And we have introduced you the invigilating days, okay? That means Thursday or Sunday. For now, it's Thursday or Sunday. Anytime in the sense not midnight 11 or 12 or anything like that. Anytime in the sense like from, as I remember, 8:30 to 6:30 evening. You can come to the institute anytime and ask questions from our invigilators. So you may think, what the point of this by now? I mean, you don't need to come here and ask about dimensional analysis, right? You understand it to a certain level, but wait for 2 months, okay? You will have all the problems in your life, okay? Then you will come, okay? And you can ask things related to any subject, okay? Not only maths, okay? You can ask things related to any science subject, okay? Don't come and ask geography, okay? Any science subject you can come and ask, okay? So it's happening on Thursday full day and Sunday full day, okay? Clear? Come and ask, come to this hall anytime, meet the invigilators and ask. And for online students, same thing would happen, same schedule will happen online. So we'll provide you the Zoom link on Thursdays and Sundays. You can join the Zoom link, get into a breakout room, ask the question from the invigilators, then leave, okay? Clear? So same program is happening for online students, okay? At the moment, you may see that, you may not see that as necessary, okay? But wait for 2 months and you'll see why we are introducing something like that, okay? And there was a question about the paper class. I mean, what the hell am I gonna do as a paper class? Do dimensions and all in a paper? So can't do a paper class at the moment. Why? Nothing to ask, okay? But we are gonna pay attention. We are gonna gradually go for a paper class. That means soon we are starting term test paper discussions. Okay. Soon we are starting weekly term test paper discussions, targeting your first term test. Okay. That's where we start things. We start with the term test paper discussions. When I have finished a sufficient amount, we are gonna start with term test paper discussions. Why? Pay attention, everyone. You definitely have to perform really well in your first term test, okay? I need you to get your maximum marks on your first term test. Why? I mean, then no one bothers you, right? That's how it works. I mean, if you have good marks in the first term test, I mean, you may have heard these kind of issues. They are taking attendance. You have to go to the school every day. Now you can't balance A-level stuff with the school. There's a lot of things happening, right? It's a very common issue in A-level students. Why? There's a lot to cover and you have to go to the school too. There's a lot of work altogether. But I mean, if you are the class first, nobody cares whether you are coming to the school or not, okay? That's how the politics works, okay? Clear? If you are the class first or second or third, nobody cares whether you are coming to the school or not, which is good, okay? So, I mean, I can remember I had practices for the first 3 months of A-levels at my school. Okay, I was in the junior national team and I was the captain of another sport. So I had practices for the first 3 months continuously. So I didn't went to the class at least one day, okay? At least one day. And it is a huge complaint, okay? Our sectional head asked me to move to the art section if you are not going to work properly. But I mean, parallelly I was working properly, okay? I went to 3 really good classes. I studied well. I was doing my stuff because I was targeting the first term test results, okay? Because then I can do whatever I do leisurely. So somehow I mean, he openly asked, I mean, it's a very valid concern, okay? If a student is not participating in the class, not doing things properly, for sure, okay, they are not going to continue A-levels properly, okay? It's confirmed. A-levels is not that easy, okay? But I mean, I studied really well and somehow I was the section first in the first term test, Ananda College. So after that, nobody cares, okay? After that, nobody cares. Even I mean, when I have practices, I just call my class teacher and tell, okay, I'm not going to be able to come for 3 weeks to the class. Just mark the attendance. Then the guy says, okay. I mean, the concern of these teachers are really valid. Why? They don't see you in the class. then they don't know whether you are working properly or not. Okay? Then they are really scared. Why? That's their job. It's their job to make sure that you are performing very well in A-levels. So they have to do their job very well. Okay, so they can't let you do your sport or society or something else, because it's not their job to make sure that you are a good sportsman. It's not their job to make sure that your society is running well. It's their job is to make sure that you are going to perform in A-levels very well. That is the main concern of your school teachers, right? Which is entirely valid. Okay? Clear? Which is entirely valid. Okay? I mean, you go to classes, but at the end of the day, you get bad results. The first one who gets blamed is your class teacher, right? Okay? So they are really concerned. So just give them the ability to forget you. Okay? Give them the ability to forget you. If you need to keep doing your sport, if you need to keep participating in your society, if you need to keep doing whatever you do, okay? The main problem for that is going to be your school teacher. Why? They are really concerned, okay? They are really concerned about you guys. So you perform very well in the first term test, then they can just forget you guys, right? Then they can just forget you guys, okay? That's how it happens. Because they have to do their job, okay? If you are anyways getting good marks, then the job done, right? Clear? That's how it works. So you have to perform very well in your first term test if you need to keep doing whatever the extracurricular activity or anything you are doing, okay? Clear? That's the first rule. So from now onwards, work properly, work from the first day properly. I need everyone to go for very good marks in the first term test, okay? Clear? Then it will be a huge support for whatever the thing you are doing additionally, okay? Clear? Okay? And because you may have seen that your sports captain kind of people who come and explain you, okay, Malli A-level and exam nam monada, we should love the sport, we should do this. Some crazy people, right? You have seen them, right? In every school, in every team, we have some people like that. Okay? The person is the main criminal for that sport. Why? When that person do A-levels and fail, when you are going to take a leave from the class, asking that you need to go for practice, the first thing that your teacher gonna tell is his name, right? Arut hitiya mege දැන් පේනවනේ. Okay? Okay, so the person is the best criminal for that sport, right? The person is thinking, okay, I love the sport, I'm doing my sport very well. You guys also should do this somehow. But that guy who's not learning well is the best criminal of that sport, right? Okay? එතනින් එහාට practice යන්න අහන සැරේට අරුගේ නමනේ කියන්නේ නේ. Okay? So don't do that, okay? If you love whatever the sport you are doing, if you love whatever the extracurricular activity doing, if you need to keep doing that, and if you really love that, you should support others to do that. That means you should perform well in education while doing that. Then even the school teachers, class teachers, everyone supports that, right? Supports that. Then they know that there's a good culture in that sport. Then they know that there's a good culture in that society where students will somehow learn, okay? So if you need, there were some questions about extracurricular activities and how to continue them. Should you stop that? No, you don't have to stop anything if you are performing well in the term test, okay? Because that's the main concern from our side also, right? If you are performing very well, if you are getting good marks, nobody cares what are you doing, right? Clear? So first term test is the main concern next, okay? You have to perform really well in the first term test. Then even we don't care what you are doing, what is the society you are in, what is the sport you are doing, we don't care, okay? That's how it works. Clear? Everyone? Let's move forward. Y equals minus x squared plus 2. Pay attention. Y equals minus x squared plus 2. Okay. Y equals minus x squared plus 2. Okay. Pay attention. Pay attention. Y. This is x. Something. Let's learn this step by step. That means what is y equals x squared? This is y equals x squared. Any graph you multiply by -1, it just gets mirrored around the x-axis. It just gets mirrored around the x-axis, right? Clear? Any graph, this is y equals minus x squared. Okay? It's gonna be mirrored around x-axis. Why? I mean, if x squared is 1, minus x squared is minus 1. If x squared is 2, minus x squared is minus 2. Clear? Clear? So this is what you are going to see, right? Clear? This is what you are going to see. Clear? If you multiply any graph by a minus value, by -1, it's going to be mirrored around x-axis, right? Clear? It's going to be mirrored around x-axis. Clear? Clear? You get the mirror image. Clear? Now what? Now what you need is, this is y, this is x, this is y, pay attention, this is x, this is y equals minus x squared, okay? This is y equals minus x squared. It is not squared of minus x, okay? It's minus of x squared, okay? It's minus of x squared, okay? When you multiply any graph by a minus mark, it just gets mirrored around the x-axis, right? Then what you need is not minus x squared, what you need is minus x squared plus 2, right? What you need is minus x squared plus 2. Clear? Then what? What is y equals? Y equals minus x squared plus 2. What is y equals minus x squared plus 2? You lift this graph by 2, right? Clear? You lift this graph by 2. Clear? You add 2 to the graph, right? Clear? That means you get the same graph minus x squared and lift that by 2. You always add 2 to that graph. Clear? Clear? So this is y equals minus x squared plus 2. So just think step by step, okay? Just don't try to think this from beginning. Just use what you know and build on top of that. Clear? Use what you know and build on top of that. Clear? Okay? So you get minus x squared. Then you lift it by 2. You get minus x squared plus 2. Clear? This is y equals minus x squared plus 2. Okay? Minus x squared plus 2. And if you need a prayer room at the interval, it's the studio behind the hall, okay? The main hall, behind the main hall, behind this hall. Okay, let's move forward. Next one. Y equals, is this clear up to now? Is it clear? Okay. Next. This is y. This is y. Then we need y equals what? Pay attention. Y equals minus root x plus 3. Same story. How? This is y equals root x, right? Can you remember? This we already know, right? This is y equals root x. Clear? Then when you multiply this by a minus mark, what would you get? When you multiply any graph by -1, it gets mirrored around x-axis. Clear? It gets mirrored around x-axis. That means you get the mirror image around the x-axis. Clear? You get the mirror image around the x-axis. So this is y equals minus root x. Clear? This is y equals minus root x. Clear? it gets mirrored around x-axis. Clear? Y equals minus root x. Now what you need is y equals minus root x plus 3. Okay. Now what you need is this is y equals minus root x. This is y. This is x. This is y equals minus root x. This is y equals minus root x. Clear? Then what you need is y equals minus root x plus 3. That means you lift the graph by 3, right? You lift the graph by 3. Clear? You always add 3 to the graph. Clear? Clear? You always add 3 to the graph. Clear? That means you get this graph and add 3 to that graph. Add 3 to that graph. Okay? Then you get something like this. Clear? Same graph lifted by 3 always. Okay? Same graph lifted by 3. Got the idea? Same graph lifted by 3. Okay? Because it is y equals minus root x plus 3. Okay? For every value you add 3. Got the idea? Clear? So this is y equals minus root x plus 3. This is y equals minus root x plus 3. Try the last one. Try the last one. Y minus 5 squared d equals x. Try this one. Ask from invigilators if you have any questions quickly. What is the first one actually? Please explain the first one. What is the first one? You don't need the negative side of x. You don't need that. You don't have to draw that. No, it's not compulsory to write any steps, but for dimensions you have to write steps for sure. Do I pay tax? I mean, nothing related to physics, by the way. Okay, try this quickly. Y minus 5 squared equals x. Draw this quickly. Y minus 5 squared equals x. And someone asked me to explain this again. I'll move here. While others are drawing this. We are going to move to dimensions again by 6, okay? By 6. Anyways, we'll take 2 minutes. Okay. Pay attention. Pay attention. Here, I mean, this is y equals x line. When x is 1, y is 1. X is 2, y is 2. When x is 3, y is 3. When x is 4, y is 4. But I need to draw y equals root x, so I'm going to check few values. When x is 0, root 0 is 0. When x is 1, root 1 is 1. When x is 4, root 4 is 2. When x is 4, root 4 is 2. So for x equals 0, y is 0. For x equals 1, y is 1. For x equals 4, y is not going to be 4, it's just going to be 2. So the points are like this. It's going below this, okay? It's going below this. So this is how the graph would look like, okay? This is how the graph would look like. Clear? The student who asked me to explain that again, the online student. Okay, this one. Pay attention, everyone. Stop talking. You just get the square root, right? Pay attention. Pay attention. Pay attention. Okay, so you just get the square root. Y minus 5 equals root x. Okay, you just get the square root. Yes, in maths you may have much better problems. It should be plus or minus root x kind of stuff. We're not gonna care about this stuff at the moment. You just get the square root. Okay, then what is y? You take this 5 here. Root x, you take this minus 5 here plus x. Now you know, right? Clear? This is y. This is x. This is y equals root x. This is y equals root x. Then what is going to be y equals root x plus 5? You lift this graph by 5. Okay? You lift this graph by 5. Clear? You lift this graph by 5. Clear? Got the idea? Clear? You lift the same graph, you get the same graph, and you lift it by 5. Okay? This is y equals root x plus 5. And there will be a paper. New students, get that paper and write your number and all, because we have to get numbers as soon as possible. We don't know when we have to shift into online mode and all. So give your details online. New students, okay? New students, give your details. And we can add you to the group and all, okay? You will be added to the group. And online students, just put a message to our hotline. Pay attention, everyone. Pay attention. Now, go to the book, page 10. Page 10 of your book. Page 10 of your tute. Yes, pressure is both HOG and FOA. Okay, both are correct. Okay. So, uses of dimensions and dimension analysis. Pay attention. Now, what is the point of learning dimensions and working with dimensions? What is the point of learning dimensions and working with dimensions? There are a few use cases of that. One is you can check the correctness of an equation. That means before being correct by any method, it must be correct according to the dimensions, right? That means using an experiment. Using some kind of experiment, you create an equation. Clear? Using some kind of experiment, you create an equation. To check whether the equation is correct or not, the first thing you should do is, you should check the dimensions of both sides. Okay? Clear? That means, for an example, let's check whether pressure equals H rho G. Let's check whether pressure equals H rho G equation is correct. So this is the left hand side. I'll get the dimensions of left hand side. It is pressure. It is pressure. Okay. I know that the pressure is equal to force over area, right? Pressure is equal to force over area. Clear? So force is M L T minus 2. If you can't remember this, you can get it from the last page of the tute. Okay? You can get it from the last page of the tute. M L T minus 2. Clear? Then what is the area? Area is L squared, right? Okay. Area means L squared. Clear? Area means L squared. Then this and this cancel out. You get M. You take this up. L minus 1. T minus 2. T minus 2. Clear? Then you check the right hand side. You check the dimensions of the right hand side. Okay. Then H rho G. That means dimensions of H, dimensions of rho, dimensions of G. Dimensions of G. Clear? What is the dimension of H? It is length. What is the dimension of rho? Density. M L minus 3. What is the dimension of acceleration? It's gravitational acceleration. But it's also an acceleration, right? Gravitational acceleration is also an acceleration, right? Clear? That means LT minus 2, right? Gravitational acceleration is LT minus 2. Okay. For now, you can get the dimensions of these from the last page, but I mean, use your knowledge about units to get the dimensions, right? You know that the unit of acceleration is meters per second squared, right? Okay. You know that the unit of acceleration is meters per second squared, right? So meters means length, per second squared means t minus 2, right? Clear? You can, to get dimensions, you can use your knowledge about units, okay? Clear? You know that the unit of acceleration is meters per second squared. Meters means a length, seconds means a time, right? Clear? So LT minus 2. Okay. So what do we get here? What do we get here? Here we get, here I have 1m. Here I have 1m. Then we have L and L minus 3. Here L and L minus 3. This and this. I get what? L minus 1, right? L and L minus 3. So I get what? L minus 1. L minus 1. Then I get here T minus 2. I get T minus 2. Clear? So as you see, dimensions of the left hand side is equal to the dimensions of the right hand side, right? Clear? So you can write, here you can write now, dimensions of left hand side is equal to the dimensions of right hand side. Okay? Dimensions of left hand side is equal to the dimensions of right hand side. Okay. Did you understand this? Did you understand this? So we can prove that this equation is correct. Okay. Clear? So write the topic, uses of dimensional analysis. Uses of dimensional analysis. Write the topic, uses of everything is included in your tutor. Okay. Ideally, you don't have to write anything, but we have to create a small note. Okay. We have to create a smaller version of our main tutor. Okay. That's why we are writing stuff. Otherwise, everything you have to know is included in the tutor. Okay. Clear? We have to just create a shorter version of our main tut. That's why I'm writing things. Okay. So that you can quickly revise things. Okay. That's the target. You can use that to quickly revise things. Okay. Okay. So uses of dimensional analysis. Then under that one, testing the correctness of a equation. Under that, testing the correctness of an equation, then write this example. Testing the correctness of an equation and write this example. Uses of dimensional analysis, under that one, number one, testing the correctness of an equation, then write this one. Testing the correctness of an equation, then write this one. Then quickly finish writing. Okay, so under that, write the equation is dimensionally correct. After that, write, after everything, write equation is dimensionally correct. The equation is dimensionally correct. Write everything. Prove that the dimensions of left hand side is equal to the dimensions of the right hand side. Then write that. Then write the equation is dimensionally correct. The equation is dimensionally correct. Equation is dimensionally correct. Next, try this. Kinetic energy equals half mv squared. Check the correctness of this equation. You can get the dimensions of energy from the last page directly. You can get the dimensions of energy from the last page of the tube directly. And kinetic energy equals half mv squared. Check the correctness of the equation quickly. Okay. Quickly prove this. Check the correctness of energy equals half mv squared equation. Then v squared equals u squared plus 2as. This is velocity, u is velocity, a is acceleration, s is displacement. V is velocity, u is velocity, a is acceleration, s is displacement. This you know, right? Okay, quickly. If you like, you can use a separate book for the exercises, or if you can do that in the main tute if you like. Okay. Yes, this is velocity. This is velocity. V is velocity. U is velocity. A is acceleration and S is displacement. S is displacement. At what time do we finish the class? 7:30. Okay. Okay. This E equals half mv squared. E equals half mv squared. There's a question, why aren't I using the smart board? Yes, I mean I used to teach lot on the smart board, not anymore. Yes, I mean for some online classes I'll be using the smart board. I mean we can't use a smart board when the attention span of students. Okay, it's a fact. We can't use a smart board when the attention span of students is low. Why? When it comes to mechanics questions, it will start at that end of the board and will end at that end of the board. In the smart board, you have to move pages. So now you can remember what happened in the previous page. So when the attention span of people or generations go low, we can't use the smart board. We have to shift back to whiteboard. So we went from whiteboards to smart boards, then again back to whiteboards. I mean, you and me, everyone, the mobile phone generation, we don't have a long attention span. So you will tend to forget. So I would write things in the smart board, move the page, then you can't remember what happened there, right? So that's why we are back to whiteboards. There's a question, why aren't we using smart boards anymore? No, you guys have a attention span of a golden retriever. Okay. Let's move forward. E equals half mv squared. E equals half mv squared. Left hand side is E. This is, I'll take from the last page directly. This I'll take from the last page of the tube directly. M L squared T minus 2. M L squared T minus 2. Clear? M L squared T minus 2. Then the right hand side. This is from the last page of the tube directly. Pay attention, stop talking. right hand side equals half mv squared. Half mv squared. So half mv squared. What is the dimension of half? It's dimensionless, just a number, right? It's dimensionless, it's just a number. Clear? It's just a number. What is the dimension of m? It's a mass. So capital M. Capital M. What is the dimension of velocity? L t minus 1. Okay, as I mentioned, if you can't remember this, use the unit. You know the unit, meters per second. Meters mean, pay attention. Meters mean length, S means time, squared. Clear? Then what we get here is m, here L squared, here L squared, here t minus 2, m L squared, t minus 2. Clear? So as you see, this is ml squared t minus 2, this is ml squared t minus 2. So I can write dimensions of left hand side equals the dimensions of right hand side. So I can write equation is dimensionally correct. Okay. I mean, this is quite easy. There's an actual reason for me to give this question. What is the reason? The reason is, pay attention, I write a specific statement after this to get marks. What is that? The equation is dimensionally correct. Pay attention. I write that the equation is dimensionally correct. I don't write that the equation is correct. I write it's dimensionally correct. That means by checking dimensions, all I can tell is that the equation is not wrong. I can't tell that the equation is correct. Okay? By checking dimensions, I can tell that equation is not wrong. But I can't tell that the equation is correct. Why? Same result I would get for E equals 50 over 20 mv squared. Okay? Same result I would get for 1 over 3 mv squared. Same result I would get for 100 over 55 mv squared. Clear? The correctness of this part is not detectable, right? Correctness of the value is not detectable. Clear? Clear? So I would get that it is dimensionally correct for anything, any number here, even for pi mv squared. Clear? So I can't tell that the equation is correct. I can just tell that the equation is not wrong. Okay? Clear? So that is the reason for that specific statement. You write the equation is correct, you get 0 marks for everything. Okay? Clear? You can't predict the correctness of the equation. You should write what? Equation is dimensionally correct. Okay? That's how it works. Okay? Clear? So few messages, pay attention. This Thursday we are starting those math sessions. You can join either online, physical, or watch the recordings. I'll provide the timetable in the group. We are going to start teaching math sessions. Pay attention. There's a high probability of me starting to teach something again. So don't pack your bags. Pay attention. These are not mandatory. If you need, you can join. Otherwise, you can skip. And the invigilating programs are happening on Thursday and Sunday. Not mandatory. If you need, you can join. Otherwise, you can skip. An explanation recording of every day's content would be provided for further explanations. If you feel like you didn't understand something, you can watch that 1 hour recording every week. For the students who can learn faster, I would start another session to finish the syllabus really fast. Again, not required. Why? Would happen in the main class too. But if you have the capacity to learn things very fast and finish things really fast, you can join, but not mandatory, you can skip, okay? Clear? Nothing is mandatory, you can skip, you just have to come to the class. That's mandatory, that's the only mandatory one, okay? Got the idea? So, nothing else. Try to finish some exercises, okay? Try to finish this paper, which is anyways difficult, okay? So you may not be able to finish more than 1 or 2 questions, or maybe you won't be able to do any question, and that's okay. That's the nature of that paper. Yeah, that's all. That's all for today. And let's meet next week. Bye.